Good morning. My name is Catherine Hayes, and I work as an industry manager in industry solutions for the South Carolina Research Authority. For those of you unfamiliar with SCRA, we have the mission to accelerate the knowledge economy in South Carolina. And we accomplish this through three primary program areas: academic innovations, where we support academic institutions to industrialize and commercialize IP; SC Launch, where we foster and fund early stage technology startups; and industry solutions, where we work with industry by scouting new technologies of interest and by facilitating and co-funding scalable pilot projects. I'll describe this opportunity relative to exoskeletons later in the presentation. It's my pleasure to moderate this exoskeleton webinar today on an emerging technology that supports manufacturing, logistics, constructions, and other industries to reduce workforce fatigue and workplace injuries. A few housekeeping notes just before we get started. This webinar is being recorded and will be shared with you after this session. Please feel free to share it with your colleagues and industry partners. I'm excited that we have several registrants interested in this topic, so we ask you to use the chat for your questions, to add links to EXO resources and suggestions for future webinar sessions. I'll be monitoring the chat and we'll break at a few points to address your questions. We'll also conduct 5 polls during the presentation, and we appreciate your participation so Francesco and I can tailor our comments. And lastly, we have a short survey immediately following the webinar. We ask you to complete this so we can plan future sessions. Let's get started as I introduce our exoskeleton speaker, Francesco Pochiro, also known as Frank. Francesco has over 20 years of experience in manufacturing, working with automotive OEMs and tier 1s in the US, Germany, and Mexico. He currently works for BMW and Greer as the Innovations and Communications Specialist for the Americas region in the Real Estate Management Department. Prior to his current role, Francesco led innovation teams at Bosch and BMW, and he introduced the first passive exoskeletons for associates in BMW vehicle assembly. Francesco co-founded the first automotive exoskeleton industry group, AEXG, sponsored by the Wearable Robotics Association. And he's lectured on exoskeletons at the US Department of Energy, Harvard University, the Wearable Robotics Seminars, the South Carolina Innovision Forum, and of course today. He's passionate and knowledgeable about exoskeletons, and we look forward to a dynamic session today. Take it away, Francesco.
Well, yeah, thanks. As Catherine mentioned, I'm here to speak about exoskeletons, and I hope that we can indeed make it a dynamic session. So let's get started. One comment to begin with and a little story. Catherine mentioned I spoke at Harvard. That I told many of my friends, I think that might have been the highlight of my career. And I told them I was done after that. I can't get any better than that. The story was kind of funny though. I was speaking at a wearable robotics trade association, which I'll talk about later. And I got to meet Dr. Connor Walsh and Ignacio Galeana. Ignacio is now the CEO of Verve Motion, and he's a student of Dr. Walsh. And I met them there, and they were really excited at what we were doing at BMW with exoskeletons. And they said that they were working on some soft exoskeletons. And I said, "Oh, that sounds really interesting. Would it be okay if I came to Harvard to see that, so we could talk about how we could maybe implement that at BMW as well?" And so they said, "Yeah, absolutely, come on by." So on my way to speak at the Department of Energy's conference on exoskeletons, I routed through Boston, and I went there to speak with them and meet with them. And while I was there, when I first met with Dr. Walsh, while I was sitting there with him and Ignacio, they said, "Hey, when you're done seeing our soft exoskeletons, would you mind maybe speaking to some of our students?" And I said, "Oh, that would be really cool. Sure. I'm very excited to share what we've been doing, and excited to talk with students." And so I had thought that it was going to be just a few students. And when I came back into the lecture hall, it was full. I mean, it was not a small lecture hall. So I'm going to go ahead and own that and take credit for speaking at Harvard and lecturing at Harvard. So yeah, that was an interesting little tidbit there. But something to mention about Ignacio, he has since gotten out of Harvard. He is doing a startup right now. And like I said, the company is called Verve Motion. And they are doing a soft robotics. The product is called Safe Lift. And I'll talk a little bit more about that later. as part of the overall exoskeletons that we're going to talk about in the different product lines. Yeah, let's go ahead and get started. And my presentation, there we go. So who's involved today? As Catherine already mentioned, myself, and we have a lot of collaborations going on here with SCRA, the South Carolina Research Authority, as well as ASTM, and NIOSH and NIST and JTech, which is all really great companies that we're working with. And then also the suppliers. I consider them all, collaborators as well. We'll get into showing some of the suppliers that we've worked with. And then we're going to get into what are the different types. First we'll get into why this is all important, why you're all here, and hopefully why you're wanting to learn about exoskeletons and why it's important. Then we'll get into the different types of exoskeletons. I'll show some of the different types that are available and some catalogs and whatnot. And I'll go into some examples there. And then we'll go back to Catherine taking over. She's going to talk about some demos and pilots that are happening. And then we'll end with additional resources that you can go and find more information. So this is sort of a exoskeletons one-on-one, but a little bit more in depth. And of course, we welcome questions all the way through. And of course, also we talked about a few polls that'll be happening. Yeah, and so these are the different, different organizations we talked about that are involved here. JTech as well, ASTM and SRA. So this was me speaking at the first Wearable Robotics Trade Association, also called WERA. This is a great resource to find a lot of information about exoskeletons. They have a great catalog, they have a great website, they put on conferences regularly. This is where I met a lot of folks in the exoskeleton community. I was invited to speak there because they had reached out to me finding out that BMW was one of the first to introduce exoskeletons in the manufacturing environment. So they asked me to come and speak about, where we were with it and what we had done. It was a really great conference. I highly recommend it. It's kind of funny also because Catherine Hayes, she went to the conference after I recommended it to her. And she went on about she said, I hope I'm quoting you right, Catherine, but you said it was the best conference you'd ever been to. And I have a feeling that was one of the inspirations for doing this webinar today as well. But a very highly recommended conference for sure. From that conference, a lot of things happened. The organizers of the conference, especially Joe Hitt, he asked us to go out to dinner with him that evening and talk about, where the exoskeleton community is, where they're at, and how what they could maybe do to bring it to a larger audience and also include more members, more people, get more people interested and excited about it. And it was there at dinner that I sat and talked with Joe and his team. And I said, one of the things that my ex-wife, she was actually in a plastics recycling trade association. And one of the things that they did really well there is that they would involve industries and support or sponsor industry facing groups. And I learned from them that worked really well. And so I said to the Wearable Robotics Trade Association, that this would be a really great thing if we could maybe sponsor something like that. So I started reaching out. At BMW, we're part of this other organization. It's called the Transplanted Safety Automotive Forum. And in there, it's all the automotive makers that are in North America. They come together to talk about safety. The motto is that there should be no secrets when it comes to the safety of our workforce. Our folks are really important. We want to keep them healthy. And so we shouldn't keep secrets. Obviously, we are very, very strict about antitrust. We will not, discuss anything that would violate any antitrust stuff. But it was very important that we share, for the health and benefit of our workforce. And so we kind of copied and pasted that, and we created this AEXG organization. It's called Automotive Exoskeleton Group. And I reached out to some of the partners there, and one in particular, Marisol Barrera from Toyota, she reached back out to me and said she'd be very interested in co-sponsoring that. So we launched this group together the first year. We co-sponsored it. I stepped away after the first year, and she continued it to the second and third year. And then she involved other folks as well. Several of those folks, I believe, are online today as well. And this is another great resource. You can go to their website. They've got a really great website there. It started as an automotive group, but we really branched out into including a lot of different industries. We involved, Boeing from the aeronautics industry. Lockheed Martin was involved as well. Of course, all the automotive supply or customers, as well as suppliers and some universities like Virginia Tech and Arizona State University, and of course Harvard as well, and then also some government institutions, including NASA. So it's a really great organization that's grown and grown. It's a great community for sharing information about exoskeletons and learning more. As this is a kind of a one-on-one, where do you go to get more information? That's another really great resource for finding more information. So why am I speaking about this today? Why am I invited to speak about this? I believe it's because I've been there, I've done that. I've seen it go from its infancy to where it's at today. I want to try to share that information with you. I still have a lot of faith in exoskeletons. I believe there's a lot that can still be done with them, and there's still a lot to come. And I have a few more information about that we'll get into, why it's important a little bit later. The history of how I got into it, specifically back before I got invited to the Wearable Robotics Trade Association. When I started at BMW in 2012, one of my first tasks was we were going away from a concrete floor that was underneath our overhead work. So our vehicles come overhead at one point, and we have to put on the exhaust and underbody panels and whatnot. And we had a concrete floor, and we were going to another ergonomic item, which was a moving floor, a moving conveyor that was a lot easier on our associates' feet and legs and body. Well, when we went from a concrete floor to this moving conveyor, the moving floor is perforated. It's a bunch of track together. Well, on the concrete floor, we were running a hovercraft around, and the hovercraft actually floated on air, and it would lift the exhaust up to the bottom of the vehicle. And so I actually had to convert from a hovercraft to something else. And my kids were none too happy with me eliminating the hovercraft. They thought that was pretty exciting that we had a hovercraft floating around. But it just wouldn't work anymore, because once that air pocket and pillow hits the moving conveyor belt, it would just bottom out. So I had to find some other way to lift this exhaust to the bottom of the vehicle. And at the time in 2012, some of the tool designers and I would joke around, hey, we should totally get the Iron Man suit. Where's the Iron Man suit? Why is that not here yet? It's 2012. We should have the Iron Man suit. So I went looking for an Iron Man suit. There was nothing really available at the time. The Iron Man suit was not there and available yet. So at the time, I had to go and look either for a lift assist, which is actually not a really good system. And it helps, but it's still a cumbersome system to have a lift assist that lifts a big exhaust to the underbody of the vehicle and holds it there while we fasten it to the bottom of the vehicle. So I ended up staying with the hovercraft, but taking the hovering part off, and I put rollers on it. So it's a really simple solution in the end, but it still wasn't ideal. It's kind of in the way all the time. So I always was looking for that Iron Man suit to come around. Well, in 2015, I happened to be in the right place at the right time. A lot of things converged. I started to lead more innovation projects, and I said to management, hey, let's look out and see what's out there. And I had come across a TED Talk, and the TED Talk was Exobionics. The CEO at the time, Russ Angold, was on the TED Talks, and he was walking around on stage on the closest thing to an Iron Man suit there was. It was a full body powered exoskeleton. And so, I reached out to them and I said, hey, what do you got? Can you come in and meet with us and walk the line and show us what's available? And so they came in, and it was really great collaboration. We sat down. They first off told us we don't have an Iron Man suit yet. And they showed us what they had. And one of the things that they showed, they had a presentation. It was a beautiful presentation. And this is the power of, speaking with people, having them in, walking the line together and collaborating, face to face or, online. When they showed me their presentations of everything that they were developing, one of the things they showed me was what looked kind of like angel wings. There was a gentleman, he was welding overhead, and he had this device on, and essentially what it was a passive upper body extremity exoskeleton. And it was supporting his arms from this cuff was underneath his bicep, essentially, or under his his lats and he was holding up his arms. I said, oh my gosh, that's what we need. We have so many job tasks that are overhead. And they said, okay, great. This is something we're developing right now. And so that kind of launched us into 2015, 2016, where we started to collaborate with them. And then along the way, we started to discover there were other companies that were just starting to get that stuff out there, like Levitate. Levitate had a product they were developing as well. And so along the way, we started to collaborate more and more with SuitX and ScaleX and Autobach. And some of them you're going to see in a little bit. But all great companies, all great products. But this is how I got into the exoskeleton business. Started to find different solutions in our facility, and then spreading that word to the automotive exoskeleton group. So that's kind of why I'm here talking about it today. We're going to go into a lot of great detail about all this stuff. One of the first things we want to ask, though, because of this is an exoskeleton 101 kind of a thing, but we're going to get into some deeper things as well. If you could maybe answer this survey real quick. It's asking what level of experience do you have with the exoskeleton? Are you beginner? Are you intermediate? Are you expert? We kind of want to gauge where you're at with this, and then also to be able to reach out to you in the future to get more information to you. And in the background, I got covered up kind of quick while you're taking the poll. In the background, you'll see the different levels of Iron Man suit. I was going to put that out there for all you Marvel nerds like myself. But the first exoskeleton that you see up there is actually the Mach 1. It was the in the Iron Man first movie where he was trying to escape from the cave. And I thought that was kind of interesting to see the history, because I'm going to actually go into the real history of exoskeletons in a little bit. And I thought that was pretty cool to see the first Mach 1, right? That's and then the Iron Man suit, of course. And then the massive Iron Man suit, if you all are as nerdy as I am, that one in the lower right is the one that he used to fight the Hulk in one of the Marvel movies. So there you go. How are we with the poll? Are we almost there? The poll is hidden from me now. There it is. All right, so we have 26% beginners so far have answered, that folks have answered, and then 33% intermediate and 41% expert. Great, great. We have a good mix. That's awesome. All right, so hopefully we have a little bit for everybody in here. Let's go ahead and jump to the next slide. Oh, I lost control. I'm back in control. All right. So again, about who's involved here, I want to definitely throw a shout out to William Belote from ASTM, National Institute of Standards and Technology. I have a little video I want to show here that's a really great video that talks about exoskeletons and the importance of exoskeletons. I'm going to play that video real quick. But so Bill will be shown in the video, but ASTM has, they are really spending a lot of time, really a lot of great efforts into creating standards and committees about exoskeletons, exosuits. They've published 2 standards providing, like it says here, the consensus terminology, as well as labeling and other informational requirements. Towards the end, when we get to Q&A, maybe if Bill wants to talk, thanks for being here, Bill, by the way. He can explain that a little bit further, but I'm going to jump over to this video real quick and let you see some of the great things that are happening with exoskeletons.
Exoskeletons are a game changer. Anything that makes us better, safer, faster, stronger, you'll be able to perform at your highest level for your entire lifespan.
In some ways, it is the stuff of science fiction. I see huge potential for these devices in the industry.
You have the military side, increasing the capability of the warfighter so that soldiers come home safe and sound. You have the medical, helping people who are paraplegic walk again. You have the burgeoning industrial side of where the industry is going. You have construction, you have manufacturing.
People that would have had to retire from factory jobs will be able to work longer and feel better. When they go home, they'll wake up without back pain. We'll see people reaching for exosuits instead of material handling devices that they use today.
The big area right now is in safety, how well these systems work, what's the risk assessment for these systems to not hurt a person.
Standards, it's the only way to get us there.
It would be ideal if there was some consensus on how to evaluate these devices so that results can be compared across groups and integrated so that we can learn more than having each individual group do it their own way.
ASTM is a mechanism by which we can have our subject matter experts bring their vision into unification with customer expectations. So folks in academia, developers who are in industry, users who are in the government, all of us have to get together to get on the same page.
I like that there's equal representation amongst small companies and large.
Standards is going to be a key part of helping us to actually talk with each other and bring a community together so that we can really move forward in this area. You're going to start seeing this as a more pervasive type technology where it's almost viewed as a tool.
We're thinking about how can we use exoskeletons for futuristic type tasks? What if we had exoskeleton devices built into spacesuits so that our astronaut population doesn't get fatigued and potentially injured?
I think you will see a proliferation of applications in military, medical, and industrial exosuits. It's going to be a really wild world.
All right. You can still hear me okay? You can see my screen now. Back to my presentation.
Yes, we've got you. Thank you.
Great. Thank you very much. So yeah, that video is awesome. I mean, that's a powerful video, and thank you guys for putting that together. I wanted to talk a little bit about why this is important, and I want to reference back to that video real quick. One of the things that I'm most proud of with exoskeletons, and one of the things that I'm most excited about with exoskeletons is helping people. The health benefit. There was a woman in that video who was underneath the vehicle, and she was doing an alignment of the wheels, and that woman, she had shoulder surgery. She had some pins that are actually in her body. She had some neck surgery. And when I brought her the first exoskeleton to put on and try, she was overly emotional during the time that we were doing that, because she was so excited that this was helping her. She wanted to keep working. She wants to be able to continue to do her job. And the relief that she was getting was substantial. I felt, this is something I really wanted to communicate to everyone, that the importance is beyond the cost savings, the workers' comp reduction, the possible insurance, reduced costs. It's that element, the human element of helping our folks. One of the biggest misconceptions that I've had being in the automotive industry from people outside the automotive industry is, oh, you guys, you shut the lights off and you build cars with robots. That is so not true. In our assembly area in particular, we have three main areas out there at the plant. We have the body shop where they weld the vehicles together. Now that is very much robotic. They're doing the welding, moving the vehicles around. Then paint shop, you have more people and less robotics there. In assembly, it's more people than robotics. And we have over 11,000 folks working out there, and the majority of them are in assembly, putting all the pieces of the vehicle together by hand with the help of tooling, fixtures, and equipment. And so for those folks, there are lots of jobs that are either at your chest level or above, and the relief that they can get from in particular upper body exoskeletons is significant. And folks like her, they want to keep working. This is a very important thing, the health benefit to them. And then also them seeing that we're trying to do something for them is very important as well. It's very important to show we're really trying. I mean, we really want to try to find things that can help them in doing their job better. I think that improves their morale. They see that we're really trying to do something to help them. That's the side costs that you don't really get, but the health costs in particular, the health benefits in particular, are very important. The costs, as I mentioned here, the workers' comp costs is very high. I think it's pretty well known in the industry. You can go online and you can Google what's a typical shoulder injury cost when it comes to workers' comp, and that's a direct hit to most companies. And that's pretty high. It's anywhere from $50,000 to $70,000. And then the cost of quality. There's a lot of studies out there that show, using an exoskeleton can actually improve the quality of the work, the quality of life as well. there's some studies out there where, when somebody's welding, for example, using exoskeleton, the weld bead integrity is improved by using an exoskeleton. I don't want to just emphasize the shoulder exoskeletons, although that's the one we have most experience with. It also goes across all the exoskeletons with lower back, leg, hand. There's lots of benefits across all those. The thing about exoskeletons is, we do the best that we can to try to find an ergonomic solution that doesn't require exoskeletons, but in a lot of cases, we just can't find that solution. And so exoskeletons is another tool in our toolbox that we can use. I thank Marisol for that. She was actually mentioning that at our last Automotive Exoskeleton group meeting. So the Automotive Exoskeleton group meeting is a great meeting for, finding, collaborating with everybody and talking about the different, ways to use it and where to use it. One of the things that came up in the last meeting was, where do we find a location to use these? Well, you go and find the terrible jobs, the jobs that, people are either, they're hurting. Most companies like ours, we keep track of that. We have, heat maps of the different locations showing where are we having the most injuries. It's a very, easy way to go find where the injuries are and then try to ergonomically improve it. And if you can't, exoskeletons is possibly a tool that you could use to improve the situation dramatically. Try to find those terrible jobs that people are not happy doing. That's usually a first indication, and try to improve them. So those are some of the reasons why we're here today talking about this. The next thing is about return on investment, building a business case. Again, the workers' comp costs here, this right here is from the National Safety Council. You can see through here for neck injuries, leg injuries, arm and shoulder injuries. The costs on average are around $40,000 to $50,000. It definitely depends where you're at, but you can see the blue line is definitely jumping up into the medical field as well. So this is not just for automotive exoskeletons or automotive use. This is across all industries as well. My significant other right now works in the medical field, and she does scanning of hearts, ultrasounds, and she says that their industry has one of the largest injury rates for shoulder injuries, and they could also benefit heavily from exoskeletons. So, we need to consider this something across all industries where you're doing any kind of work, where you're straining your body, whether it's bending over, whether you're lifting something at your chest level or above. The cost calculations are relatively easy to do. I mean, you can easily go in and dig into the information that you have at your company, find what a workers' comp costs, find what the quality costs, and put those all in a business case calculation. It's not a hard sell to management when you're saying, hey, we want to buy some units, try them out, and then buy some units permanently. That cost calculation is not a difficult thing to do. And, there's a side cost calculation you could do as well. How do you put a cost on, helping your folks out and having them continue to work and their morale being improved and their, quality of life and quality of work as well. I have some training notes here as you see me looking to the side just to make sure I'm not missing anything that I wanted to mention. The one last thing I want to mention about the costs and the benefit, there's proof in the pudding out there. If you look around, you join some of these groups, you go investigating, you talk to some of the industry experts, you will find that there is proof in the pudding. There's probably someone online here, I'm not going to name names, but they have mentioned that there is a before and after at their automotive manufacturing site, where before they put exoskeletons in to their job tasks, they had a high rate of injuries in the shoulders. They then had exoskeletons deployed. Everyone who worked in this job position wore exoskeletons, and they have not seen injuries after that. There's no more stronger proof in the pudding than that right there. That is enormous information. Well, there's nothing published about that though. It was a verbal confirmation about that, but it is out there. There's also plenty of studies out there. When I was getting it, even back when I was getting into it in 2016, there were plenty of studies being created then. There are studies created every year. Simple Google searches will find lots of those studies. Also talking to Bill from ASTM, he is very open and willing to share information about studies that they've been doing. Catherine will also talk about some studies that they want to try to do as well. They will be doing as well, not try, they will be doing. And these studies continue to show the benefit of exoskeletons before and after on the human body. So there's definitely a lot of proof out there. There's definitely a lot of studies out there that show the benefits of it. So the next thing we're going to do here is we're going to get into exoskeletons. What are the different types of exoskeletons? I'm going to take a quick pause though. Catherine, are there any questions that you see popping up? I don't actually see the chat. Is there anything that we want to jump into? Maybe a question or answer right now or not?
No, our participants have done a great job of sharing resources and links, so appreciate that.
Cool.
But please feel free to add your questions and I'll monitor that. Thanks.
Great. Awesome. So what types of exoskeletons? I love this little picture right here. I always think back to the time when Russ Angold and Exobionics came in to visit with us and showed us their first presentation. We were obviously asking for the full-blown powered exoskeleton. What they showed us was this picture and they said, is this what you think of when you think of an exoskeleton? And what this is this is from the movie Aliens, and that's Riley, and she's in a caterpillar exoskeleton trying to fight the aliens. This was a pretty funny one for me, but they do not have this. This is not real. This here is also not real, but I thought this was a pretty cool exoskeleton. This is a design firm that's actually created a whole bunch of stock photos. I went on to Shutterstock and I downloaded this for free for signing up. Its credit goes to Gordon Kopf. It's a company that does a lot of pictures like this and studies like this. While this is not real, it'd be pretty cool to get. But there's a company called Frost and Sullivan. They are a consulting company, American business consulting firm. They do market research and analysis, and they're all across America, Asia, Europe, Africa. And one of the things that they mentioned was global industrial exoskeletons market is about to boom. They also said that the global industrial exoskeleton market is expanding rapidly, driven by high injury costs and aging and shrinking skilled workforce across the sector. Yeah, all this is true. I think, exoskeletons are booming. They will continue to boom. They're continuing to get better. The suppliers that we've worked with are continuing to tweak and make them better. I see nothing but upward growth here with more and more excellent exoskeletons coming out, better designs, with more sensors being incorporated into it to not only collect data, and then also micro motors being put in to help assist. So yeah, I think that's another reason why this is so important to be involved in the exoskeleton world and community, and possibly introduce it at your own companies and then spread the word to other industry partners. The types of exoskeletons we're going to look at here, we've looked into all these. I know that the partners in the Automotive Exoskeleton group have looked into these. We've looked at full powered exoskeletons, shoulder exoskeletons, back exoskeletons, legs, and hand exoskeletons. What we're going to talk about first here is full powered exoskeletons. This is kind of fun here. This is the first fully powered exoskeleton that was ever created. And this was created in 1965. It was 1,500 pounds. And it was created for GE and military use, and it was created at Cornell University. I thought that was pretty awesome. I don't know if everybody knows where the first exoskeletons were created. Previously, it probably would have been in science fiction, but this is the first one in reality. Then we get to the powered exoskeletons that we have today. First one to mention is Sarcos. I'll also mention Lockheed Martin twice, and as well as Suit X has a little bit of power in there as well. When it comes to the leg exoskeletons. This corporation, Sarcos, was a DARPA military research and development firm at first, and then they've gone commercial in the past few years. They invited myself and industry partners from Delta and Schlumbacher, Caterpillar, Delta. They were trying to represent all the industries. GM was also involved at one point. Toyota was involved as well. GM might still be involved, but they asked us all to come together to help collaborate on a powered exoskeleton suit. They wanted to see, where could we go with this? And they were in development of a powered exoskeleton suit. And this is a fully powered exoskeleton suit. that a person can step into. It's got 3 battery packs on the back. They can hot swap the batteries to continue working. We had some ideas. We were going to try to use this once we got back into looking at powered exoskeleton suits, where we could eliminate lift assists. If you've ever been in an automotive manufacturing site, you'll notice that there's a lot of lift assists. Whenever you get anything larger or heavier than 30 pounds, approximately 35 pounds, you have to actually have a lift assist helping a person moving that part to the vehicle and holding the part there. The problem with lift assists is that they are very cumbersome. They're very large. They're a fixed point in the assembly line. You cannot easily balance an assembly line by moving a lift assist from one location in an assembly line to another. It typically requires a full shutdown. It's very, very expensive to first install one, and then to move it, you can only do it during a shutdown. So you have to really rush around in a week time to move it. If you've ever been involved in something like that, you know that it's chaos trying to get everything, shut down, move stuff around in an assembly line, get it back up and running quickly. So we saw a huge benefit here with a powered exoskeleton suit, where you could actually have a person walk into an exoskeleton suit, walk to the line, pick up the exhaust, for example, lift it to the bottom of the vehicle. You could release your hands from the exoskeleton, but the exoskeleton still holds the exhaust there. And then you use your power tools to fasten the fasteners to the bottom of the vehicle. We also saw a potential for great benefit here in our rework area. So in the rework area, they don't have all the lift assists that you have all through the assembly line. So a lot of times a person we have special circumstances where they're not using a lift assist because there's no other way to basically handle maybe a tire. Taking a tire off of a vehicle is quite heavy, actually, especially when you're talking like an X5 or an X7. Those are big tires. So we saw a great benefit to be able to use an exoskeleton to take wheels and tires on and off, not only in the assembly line, but also in the rework area. We could see across the board benefit of using this in all of our dealerships where they're working on vehicles. So a lot of potential with full powered exoskeletons to be a very universal exoskeleton for folks to use all across the board. Yeah. So the next exoskeleton we're talking about are the shoulder exoskeletons. These are passive mostly. They don't have any power, basically wheels, pulleys, wires, cables, springs. You see some here. This is not a full representation, obviously. I just have room for a few here on the slide. But Autobot, Levitate, Exobionics, ScaleX, SuitX, Kamal. There are certainly others out there. The shoulder exoskeletons are passive. These typically are helping your arms when you're lifting your arms overhead. It doesn't completely take over your arms. It doesn't basically lift your arms up and then you don't have any muscle power at all. It's supporting it and reducing your muscle strains and your needs by about 30%, 30 to 40%. The suppliers can correct me on that if I'm wrong, and obviously reach out to them to find out more information about where they're at currently today. But as you can see, it's a support for under your arm when you're lifting overhead or at your chest level and above. We saw great benefits in using these in the underbody of the vehicle when we're working on the underbody. So we do tilt our vehicles on their side to help with the ergonomics, but even tilting the body of the vehicle on its side, we still have to lift our arms to shoulder level and above oftentimes. In other parts of our facility, the vehicle is actually completely overhead and we're lifting our arms straight up, which is some of the stuff that you saw in the video there. You saw that our folks were lifting their arms straight up and holding a tool. And if you could imagine doing that over and over again, it gets quite tedious and you get a lot of wear and tear on your shoulders. The muscle strains are significant. So being able to reduce those strains significantly reduces the chance of injury, significantly improves the work, the associates' environment, their the work-life balance in there. So the shoulder exoskeletons are, like I said, passive. One of the things I want to mention is if you go to Wearable Robotics Trade Association website, you'll see a full catalog. These are some more. Some of these companies are no longer, but there is a great full catalog there. I want to credit Associate Professor Dr. Thomas Sugar. He's also a member of the Automotive Exoskeleton Group, as well as Wearable Robotics Trade Association. He put together an very extensive catalog where you can see all the exoskeletons we're talking about today and further and beyond. You can find out little bios about the companies there. Certainly a great resource to reach out to and find the current companies that are working with exoskeletons.
Hey, Francesco, Bill Balat actually added that catalog link, so we're good there. But just a time check, it's 12:11.
Okay,
So.
Thank you. So we'll move a little quicker then. The back exoskeletons here, you see Suit X, Levo, and HeroWare. We've tried using these in logistics. We're still trying them in logistics. A lot of picking from boxes, lifting while bending over. These are great exoskeletons. A lot of the different organizations are using these. I highly recommend them. Again, there's a catalog that you can look at all the different back exos. This is one also that I was mentioning earlier with Ignacio Galeana, the CEO of Verve. That's another back exoskeleton that's recently coming out. Reach out to them to find out more. And then the leg exoskeletons, this one I will mention, Suit X has a little bit of power in there where you can actually get a little bit of a bump up when you're trying to rise back up. Also, they have communication between the legs to communicate and also collect data. The Noani is more like a stool that kind of walks around with you as you need to sit down, take a relief. You can still be able to work on the vehicle or the anything in other industries, as well as Lockheed Martin on the right. That one does have power in as well. I was able to put that one on, and it actually helped me to lift a box that was weighing probably about 50 pounds. It was quite fascinating, and it really worked well with my normal gait as I was walking up and down stairs as well. Again, catalog is out there. I encourage you to reach out and find out about that. And then the hand exoskeletons. So this was something I saw at the Enterprise Wearable Trade Association, where we found out that Bioserver had an exoskeleton for hands. This is something we came across at about 2017, where we found out that GM and NASA had paired up to create this robo glove. They have sensors in the fingers. This again goes back to that original one from 1965. But Bioserver has made one. Deo has also got a hand exoskeleton. I encourage you to reach out. This is a great one for gripping. There's a lot of strain in the hands, as well as we have a trigger finger situation ergonomically, where we're grabbing power tools and we're squeezing the trigger to fasten things to the vehicle. And that can be fatiguing on the hand, the joints, carpal tunnel, all that. So this is something we're also very interested in, is hand exoskeletons. I already had mentioned different places that we've used them. Again, I'll just reiterate, trying to find the right place to use them is not that hard. You just want to bring in companies that are doing exoskeletons, walk the line, look together. You'll find the collaboration is fantastic. But I typically would look for those jobs where we either had high injury rates, jobs that people complained about, that they had muscle strains and stresses. So yeah, where to use them. So yeah, the next poll here, which interests you the most? We'd really like to know what you'd like to know more about, possibly, what kind of exoskeletons are of interest to you. So please go ahead and answer that poll. What's interesting about the exoskeletons is there's a lot of information out there. As you search, you get deeper and deeper into it. The more people you can talk to, the better. So yeah, it looks like we're interested in powered exoskeletons, about 50%, and shoulder overhead work 67%, and supporting the back, as well as it's pretty even spread across the board. Very good. I appreciate that very much. One of the things about exoskeletons is, how do you evaluate them? And we use different tools. I encourage you to do body mapping, where you find out where the strains, talking to people, going from quantitative to qualitative data. This is very important to find out, where should we be using these, where are the strains and stresses, and then evaluating the reduction in the strains and stresses over time and using the exoskeletons. A couple different, ways of doing that, obviously with body mapping. I really like that. A general questionnaire. Develop this on your own or find the resources that are online. They're very much out there. One of the really great resources is the NASA TLX. This is basically a task load index. I like this one. I'm actually going to read you what it is so I don't mess this up, but it's a widely used subjective multidimensional assessment tool that rates perceived workload in order to assess a task, system, or team's effectiveness or other aspects of performance. It's developed by Human Performance Group at NASA, the Ames Research Center over a 3-year development cycle. It's included in more than 40 laboratory studies, simulations. It's been cited in over 4,400 studies, highlighting the influence of NASA TLX has had in human factors research. It has been used in a variety of domains, including aviation, healthcare, obviously is automotive as well. So yeah, it's a really great resource for using for also RULA, which is the rapid upper limb assessment tool. This is a great tool if you want to evaluate the upper arm, obviously exoskeletons or the arm exoskeletons, great tool as well. So strategies, I'm not going to go too in depth here. There's a possibility we'll be doing additional webinars and I'll get way deeper into strategies. I love this little pictorial though, laboratory flow chart. Does it move? Yes. Should it move? No. Use duct tape. Does it move? No. Should it move? Yes. WD-40. This is something that I use often in my own garage. But strategies are important. So early on, we developed a flow chart like this and trying to determine, what's the right exoskeleton to use, how do we evaluate it, which ones do we introduce? There's quite a bit more detail we can go into with strategies. There's really 2 strategies that you should work on. One is the first introduction with meeting the suppliers, talking with management, walking the line. And then the next strategy is really how do you get from, we've got some ideas on exoskeletons where we want to use them to actually implementation online or in the facility. Something to talk about briefly is mandatory versus voluntary. Mandatory PPE is something that some of the Automotive Exoskeleton Group members have had success with in calling it mandatory PPE. So personal protective equipment. This is a great way to go. But it doesn't work for everybody. This is one of those case-by-case scenarios and company-by-company scenarios. In cases where they have mandated it to be PPE, the results have been outstanding, to say the least, where they've gone from high injury rates to very low or no injury rates. So that's something that is a case-by-case. You'll have to determine if that works for your facility and your management structure and style. Voluntary also, go out there and ask, survey, figure out who would be willing to wear it. Those are usually the best people to be the ones who become advocates for introducing exoskeletons into your company. I highly recommend asking for volunteers for that. Sorry, Catherine, I took a lot of time. I tend to go sidetrack and long-winded and tell stories, but I'm going to hand this over to Catherine now so she can speak more about demo and pilot.
Thank you, Francesco. And if you could advance the slide, that'd be great. I'd like to give you an overview of the upcoming Exodemo and the proposed industry pilot project. Just a little bit of background. In 2019, SCRA Industry Solutions initiated an industry forum with 10 companies cross industry verticals, aero, auto, and industrial. And from their input and plant tours of me observing operations, getting to know folks like Francesco and going to Warecon, Marisol, and Bill and others, and also specifically JTEC's keen interest. SCRA will support an exoskeleton demo and potentially pilots and implementations. The first demo will address manufacturing and logistics. I'll explain that in a little more detail. It's scheduled November 11th and 12th at the Manufacturing Conference in Greenville, where SCRA is a conference partner. We'll sponsor the opening breakfast on November 11th, and we've invited an EXO expert to speak, do a tech talk. And we will de-risk this demo by subsidizing the cost for the vendors to come and by providing access to try on and experiment with multiple EXO devices. If you'd advance, that'd be great. Thank you. Okay, so to simplify a pretty complex experiment, the demo registrants will have the opportunity to try on multiple EXO devices and execute 2 tasks: the lower back box handling and task 2, upper extremities overhead assembly mockup. I want to thank Wearable Robotics Association for this image, and ASTM and NIST for the references on test apparatus and methods to demonstrate load handling and movement to design the demo. Next slide. So we've reserved the Santee room at the convention center. So we'll go through an explanation of the demo and do a pre-survey on your previous experience and preconceptions. We also have reserved booths that are 10 by 20 feet, and they're pipe and draped with restricted access. So the participants will execute the tasks on their own without being influenced by a bunch of folks watching them. We anticipate 5 vendors to set up the 2 tasks depending on their device applications. We'll run the ABA process, which is 5 times without the EXO, 5 times with, 5 times without, and then do a post-survey experience. If the schedule permits, we'll also invite the EXO vendors to do a tech talk. Next slide. So why would you or your colleagues or industry partners be interested in this? You'll have the opportunity to see a variety of commercial EXOs all in one location, and this really reduces a lot of your time and cost. Participants will be able to try on multiple devices and execute the 2 tasks to simulate a workplace environment. And this may sound trivial, but JTech and I have learned that it's time consuming and expensive to have access to the EXO devices in a manufacturing plant. So the demo gives a good opportunity for exposure. You'll hear about next steps to pilot, introduce, and implement EXOs in your workplace. SCRA is providing financial and technical support to organize and de-risk the demo with multiple vendors. And lastly, with guidance from ASTM and industry partners, Tested HQ and Clemson University, as well as the EXO vendors, we're designing the demo to simulate real-world tasks. Okay, next slide. If you'd all take a quick poll, that would be helpful.
So the poll is, are you, your company, interested to participate in an EXO demo with devices from multiple vendors for a $50 fee? Select all that apply. Yes, please email information about the November 11th demo at SC Manufacturing Conference. Yes, please email information on a future demo, or no thank you. I think we're running short on time, so as this is being asked and answered, I'll just follow up with the conclusion. Essentially, what I want to speak to about in conclusion is, why would you want to do this for your folks, and what are the reasons there? It's very important for them, for us, that we continue to move the industry forward and save our people's health, their well-being, as well as reduce costs. I think everyone online understands all that. And there will be naysayers along the way that'll be negative about it. I'm usually typically a very positive person, and I'm very optimistic about exoskeletons. There'll be questions about, well, what if we put exoskeletons on folks and they atrophy? They become so used to exoskeletons. That's one of the most common ones I've heard, which is unusual for me. When I think about giving, aids to folks like wrenches or, to turn bolts and nuts, I mean, they didn't atrophy from that. When we give them lift assists to help lift heavier items, they don't atrophy from that. So I don't really like that argument. And I think, this is an aid device. This doesn't take over completely either. You're still having to move your muscles. You're still having to use your muscles a little bit, but it's reducing those strains and stresses. That's very important. When you get into full powered exoskeletons, of course, that will be taking over for you, but it's the same thing as driving a car. I mean, you're using a device to help you get from point A to point B. But overall, we should do this for our folks, improve their quality of health, improve their willingness to want to keep working, also to help our companies, reduce costs. I believe there's discussions about insurance rates potentially being lower if you can show proof that you're using this. I think these are all excellent, reasons to use exoskeletons. I highly encourage you to look into it, highly encourage you to spread the word. I just see nothing but potential growth and excellence coming from what's out there. And I will make one last note that all of the suppliers I've worked with have been excellent. They're all trying to improve their exoskeletons. They've got great products. I will not endorse one over the other. I'm not allowed to do that, of course. But I will tell you that they are continuing to improve. They're very excited about it, of course. We're very excited about it, of course. And I see nothing but great things coming. And I appreciate everyone who's helped in talking about this. I appreciate everyone who's been members of AEXG, the Automotive Exoskeleton Group. I appreciate the Wearable Robotics Trade Association, and thank you, Catherine, for SCRA and all your support.
Hey, Francesco, would you advance the slide deck just a minute? We have another poll. I don't have a chance to talk about the pilot project, but you have your resources as well. Sorry. We were going to, ask another poll about future webinars. If the folks would like to learn more, I'd love to have you respond to this poll, please.
This one was are you interested in a pilot poll?
Oh, okay. That's also of interest to us because we were SCRA is looking to help de-risk a industry pilot with industry match, and then future webinars. Thank you. Go ahead, Francesco.
Yeah. So you'll see this slide deck. There's some resources that I put in there at the end, and some shout outs to different organizations. Again, I appreciate it. While you're answering this poll, go ahead and leave the poll up, I guess, and you could ask questions if you have any questions this time. I'm sorry we went a little bit long here. I guess we have a few minutes, but yeah, any questions?
So we do have a question about where we could find certification required for EXO products.
So certifications for EXO products, I believe probably your first best source for that. One would be to talk with the Automotive Exoskeleton Group. A lot of folks are in there talking about that. That's a great resource to find out more. I don't exactly know the exact people to talk to or the organization to talk to. I would also look into NIST, National Institute of Standards and Technology, as well as ASTM. Bill is on the line. If he has a better answer for that, I encourage him to chime in. Yeah, I don't know exact organization for that right now.
Yeah, so Bill just added that ASTM is working on developing tests and certifications for exoskeletons through the F48 committee.
That's correct. Yep. Great.
We don't have any other questions. Folks,
that means I did a great job.
I'd like to thank everybody for participating today. We look forward to having you engage further in exoskeletons with us, both on the research side and then on the deployment side in manufacturing and logistics applications. Thanks so much, Francesco. I think you did a great job. I appreciate it. And if any of you are interested in future webinars or actually any more information, please feel free to contact me, Catherine.Hayes@scra.org. I think we're close to time, Francesco, and I don't think we don't have any other questions. So thanks so much.
Thank
you. Have a great day, everybody.